Did you know that ESP32 microcontroller is capable of showing seamless animations with relatively high frame rate on parallel TFT screen? And let me tell you something, the animation design you have seen can be done easily using LVGL Library and SquareLine Studio. In this video, we are going to use SquareLine Studio to design a graphical user interface to display temperature, humidity, and air quality sensor data with eye-catching animations. We are going to let things move on a screen today, so without any further ado, let's put the show on the road. Turn your dream project into reality with PCBWay. I've personally used their services to produce my own prototype for future IoT projects. Ordering your own PCB has never been easier before. With a lot of features, PCBWay has launched the 7th project design contest. Who knows, you may be one of the winners who is going to get quite nice prizes.
Alright, so here's the setup that we are going to use along this tutorial. We have been using the same board for several times. So as you may have remembered here, we are printing the air quality data on the screen, and we have also temperature and humidity sensor. We are using their data. So we can use the side buttons to navigate between two screens that we had already designed using SquareLine Studio. So this time I'm going to show you the animations that I have added to the firmware. So here I have added this segment that shows the temperature and the humidity, and I can remove it by holding the down button pressed. For 3 seconds you will see the segment has disappeared, and I can get it back by holding pressed the up button for 3 seconds again. And I can do the same thing in the other page, but of course with different animations. So I can extend this bar that's going to show the VOC data with this pointer rotation animation. And I have also the VOC is displayed in form of text. And I can remove it as well using the down button. So you'll see that the gauge will disappear and then the bar will shrink. So now we are going to discuss how these animations have been designed on SquareLine Studio and then implemented on the ESP32 firmware using LVGL library. So now let's jump into SquareLine Studio and proceed from there.
Alright, so here is the SquareLine Studio program where I have designed the graphical user interface for my hardware. You may remember from the previous tutorial that we have designed this screen together where I'm printing the VOC value, the air quality value index, and of course here we have the gauge. Let's run the simulator on the first screen. As we have covered from the previous tutorial, this gauge will have the value that's being obtained from the air quality sensor. And I've added this segment where I'm displaying the surrounding temperature and the humidity. So this will get updated as we read data from the HTC 1080 temperature and the humidity sensor. But apart from that, in this tutorial we are going to cover animation part. So on this screen I have a dedicated animation in order to show and hide this segment. So the hide animation will make this segment disappear. So if we run the animation and I press on the hide animation, this will disappear, and if I go to the show animation, this will let the temperature and humidity segment appear again. And I've actually done that by selecting the panel that I'm going to apply the animation on, and it's the panel 8. I have it over here. So if I exit the simulation, so this segment will get the animation, and here I'm selecting the type of the animation. I'm selecting the opacity value, which is going to determine how visible this segment is going to be. So this will vary from 0 to 255, the maximum value for the show animation. And you will notice that in the hide animation, this will be reversed, so it's going to disappear at the end. So this is what happens. Of course, we can always add a new animation by giving a name to it, say banana. and then we hit the add animation button. So here we see that the banana animation has been added to our list, and then we are going to select to which object the animation is going to be applied. So let's apply it to this gauge that we have. It's in the arc1, so we are going to select that object, and then here we are going to select the type of the animation, whether it is a change of size, position, opacity, angle, zoom in, zoom out. So let's say we want the animation to let the object move along the y-axis, and then we are going to hit the add button. So here we have the start end values, delay time, and number of playbacks of the animation, and the type of the movement. So here if you look at the start and end value, here we have the relative option is activated. This means the object won't move at the start value, and the movement will end after moving 100 pixels starting from its initial position. So now if I run the simulation and start the animation, you will see how the arc will move. Of course there are more types of movement, so we can try this one for example, or maybe this one. So you will notice that using this animation the arc will bounce. Anyways, we can always delete the animation at any point. I don't need that, so let's get back. Of course, when exporting the user interface files, a dedicated function for this animation will be generated, so you can use it on your own code, and we'll cover that in a few minutes. Okay, so now let's move to the second screen and see how the animation has been done over here. So first of all, we have a few animations here. So I have an extendable bar over here. We have seen this at the beginning of the tutorial. So I have here the extend and shrink animations. So let me run the animation and see how everything works. You can see that this animation is applied to panel 3. So if I run the animation, you will see that this will shrink. And in the extend animation, the extended bar will get back to its normal state. So if we have a look at the other animations that I have implemented, so here I have the remove VOC indicator. If I run that, you will see the VOC gauge has disappeared, and when I add the VOC animation, it will appear again. And also I have here an indicator animation. So if I run that, the pointer of the gauge will get to 0. Okay, so we notice that image2 is selected as the object of the animation, and the animation type is angle. So when the animation starts, the angle of the pointer will change. So let's go to the image2 object. Here it is. So this pointer is the object that's going to rotate. So here, while we are in the pointer settings, you will notice that I have modified the center of the object so it can rotate in a logical manner, and I've managed to do that by setting these values. So let me show you what happens when we use the default values. Let me move this to here, and I will use the default values, remove the rotation. So now when I try to rotate this object, say that I want to rotate it 90 degrees, you'll see that the whole object moves because the center of it is located over here. However, the center that we are aiming to should be over here. So if we get back everything to its normal, so this will be 110 degrees, this is 23, and this is 60, and I will move this to its normal position. So now let's run the simulation, and in our animation the movement will start from 110 to minus 110 degrees, and I've set the animation time to be 3 seconds, so it slows down. So now let me show you the difference. The animation time currently is 3 seconds, and the movement type is set to be this type. So I can slow this even more by setting it to 5 seconds, and if I run it again, you will see that it's even slower. This was actually everything related to SquareLine Studio and implementing animations. The place that I have obtained this, actually I found this gauge on the internet, and then modified it to serve my purpose using Canva, and separated both the gauge and the pointer so I can use them separately in SquareLine Studio. Okay, so after finishing everything, we need to export our user interface files and import them to our project. So I have done that. Let me show you the output of SquareLine Studio. So we'll have everything over here. So in the user interface source file, you will see all the animations that we have worked on. Here you see the remove VOC indicator animation, the one that was related to rotating the object, and all the animations. So we need to import that to our ESP32 S3 project, and here we are. So here you may notice that I've imported both screens. This is the initialization of both screens that we have designed on SquareLine Studio. And let me show you the animations. Yes, here you can see extend animation, shrink. Here we have the hide, and here we have show, add VOC, remove VOC, and last but not least, the indicator animation. Usually the generated functions on SquareLine Studio, they take two parameters, and they are the object that the animation is going to run on and the necessary delay. And according to our design, we have already selected the object, so I'm actually including the object inside this function. I don't want to pass it from the upper layer, so this actually suits my purpose. And the other thing is the delay. The delay is adjusted depending on the animations that I want to run together. So let me show you how I've used these animations. So all the animations that you have seen and the switch between pages is done in the screen navigation function. So this is actually passed from the upper layer, where different actions can be passed depending on the pressed button and the way of pressing it, whether it's long press or one click. So we see that in the main layer. So I have two functions that are going to handle up and down buttons, and they are separating the action, whether it is long pressed or just single click. So here in the screen navigation function, depending on the past action, we are actually either switching the screen or running some animation. So we can see that on this side as well. So let's take this as an example. So in the menu enter scenario, and while we are in the temperature and the humidity page, these three animations run together. The upper bar is extended, then the VOC gauge is added, and after that the indicator animation starts running. So these three animations won't happen at the same time because we already have an adjusted delay. So this indicator animation will start after 500 milliseconds after calling it. There's actually one last thing I need to mention, and it's related to updating the data while the animation is running. So let me go to the VOC update function, and we have it over here. Alright, so here in the VOC index update function, I am taking the VOC index data from the sensor on the main layer and passing it here to update all the variables that are related to the graphical user interface, and one of them is the gauge in the temperature and the humidity screen. So you'll notice that I am only updating the value of the gauge only if the animation timer is paused. This will actually prevent the animation from getting interrupted while running. So now let's see what's happening inside the VOC gauge angle update. So inside the gauge we have a pointer to rotate, so we need to convert the VOC value to an angle. That's why I have VOC to angle conversion function. And we have a text that we need to update, and we have it over here. So this data gets converted to string and printed directly to this text object right away. And over here I am actually scaling the 500 value in order to suit the angle of the pointer. You can have a look at these two functions. I have VOC to angle and angle to VOC. You will need to implement your own function if you are using another scale. This actually brings me to the end of this tutorial. Here you can see the repository of this project. I have been doing several tutorials using the same hardware, and they are all inside this repository. And you can navigate between the sensor project within this repository. So I hope that you have learned something new. Share this video among your friends and tell them about Useful Electronics. See you in the upcoming tutorials, and bye bye.